So at this point, we're going to take a look at part 3. We're going to be doing a competitive exclusion virtual lab with the paramecium. There's 2 species that you're going to identify. You should be wrapping up your relationships, your symbiotic relationships. And what I want you to do right now, if you already have not started, I know a couple of you are ahead. Scout, you're ahead. Go ahead and find the answers to your pre-lab questions. So what is exponential growth? I've given you an example here. I went into the text, I highlighted where the evidence was for that answer, and then I copied that answer and I pasted it to question number 1, asking what exponential growth is. So take a few moments to do that. Define limiting factor. What is carrying capacity? Incidentally, this one right here is super important. That's a concept that we're going to revisit. It's one that you should add to your notes, because this particular concept is one that often is either misunderstood or easily forgotten, and it's very, very important by way of populations and what happens to those different populations for different entities in the community. Okay? So go ahead and finish this. I will get the door. I'll be right with you guys.
Why are you late? Why are you late?
Some of you guys, as you're writing that answer, I think it's really nice if you use different highlighted colors, because it'll show specifically where you grab that evidence from the text. So when you find carrying capacity, for example, highlight it in another color. Stick that answer in that same matching color here. Just a really good visual to see exactly where that info came from. Yes, Rafa?
If we don't finish this homework,
No, you're going to finish it, because we're going to start the lab in just a few minutes. I'm giving you about 4 or 5 minutes to do this portion, okay? The only exception to finding these in the text would be questions number 7 and 8. And these are important. 7 is, what is the purpose or objective of the lab? Why are we doing this? What do we hope to get out of this? The question number 8 is your hypothesis. So once you take a look at what we're doing here, what do you predict is going to happen with these populations? Fast workers over here. Where are we at? You gotta move a lot faster home. Come back to this later. I need you to stay with me. So right now, find these definitions and stick them in place, okay?
What you can do is maybe help get one of these guys squared away. So the actual lab. Okay, the actual lab.
And then this is a hypothesis for the actual. Okay.
Correct.
So I can't write this yet because.
No, I want you to do that. So
Oh, okay.
the objective of the lab, if you go back up to the title of this activity, I think you'll be able to kind of infer what the objective is. And then I'm going to explain in just about 2 minutes here what that lab setup looks like, so that you can kind of come up with your own hypothesis, okay? Are you okay?
so we don't do 7 and 8 yet? Get to wait?
No, try, you can definitely do 7. 8, I'm going to talk about like 1 minute now.
Okay.
Wyatt, how are we doing?
Good.
So just kind of looking back here, look at this really quick. Hunting for info. If you look here. So it says give you examples. What are some limiting factors, some examples of limiting factors?
Food and water.
Food and water would be great examples. So highlight that and stick it on that question. You good, Matthew?
What's up, boys?
Well, I'm ignoring that. All right, where are you at? So you see where it's talking about that? So highlighted. So right here. So how do you define exponential growth in math? Scout, you asked, you said.
So exponential growth in math is like when something, it starts off at 0 and then let's say it goes from 0 to 2 and then 2 to 4.
Okay, so if I was
4
graphing,
to 16.
if I was graphing something like that, how would I draw that curve? Yeah. Bingo, bingo. So when you look at the data that we collect from the populations of the two genuses, or the two species of the genus Paramecium, what do we see? Do we see exponential growth? Do we have a plateau? Do we see populations decline? That's what we're going to be kind of analyzing today. So again, you're going to have two Paramecium, and I'm going to help you with question 8. You're going to draw a hypothesis in just a moment. These two species of Paramecium, they're going to be in test tubes, okay? So test tube A will have Paramecium aurelia in it, just by himself, his own little habitat. Then you're going to have test tube number 2 with just Paramecium caudatum. He's all in his own little habitat. The third test tube is going to have a mixture of the two species together. So what happens when they're alone, population-wise, and what happens when they are in the same test tube together, okay? So you're going to hypothesize or predict what you think will happen. So take care of number 8, and then we're going to move on. Everybody doing okay? So what is carrying capacity, Jefferson?
Capacity. The carrying capacity is the greatest number of individuals a given environment can sustain.
Good. Okay, so say that really loud for everybody. Carrying capacity is what?
It's the greatest number of individuals a given environment can sustain.
So if you've got Paramecium aurelia in a little test tube, how do you know if it's reached carrying capacity? What would you expect, Matthew?
The population's at a stable rate.
Okay, so maybe you're not going to see exponential growth any longer.
It's just gonna be flat.
You'll get stabilization, right? Like almost like this homeostasis equilibrium of sorts, right? What else would you predict could happen? What would be limiting factors for carrying capacity? What kind of things would limit population? What would you say? Food and water, exactly. So in this experiment, we're going to actually put the food in. We've got this given space, this given volume in a test tube, and then we're going to stick some Paramecium in there, and we're going to watch what happens over the course of several days, 16 days in fact. So you guys have this data table. If you'll open the data table up, I just want to walk you through a couple key points before you start your lab. Number 1 is the days. You're only going into the lab every couple days to take counts. You're counting the populations. So day 0, the day you put them in the test tube, how many did you put in there? Okay? Day 2, you're going to come in, you're going to count them again. Day 4, you're going to come and count again, so forth and so on. Notice, everybody look at the board for 1 second. Eyes up here, real quick. Notice that on this table, they have P. aurelia first. Okay? When you look at the virtual lab, you have to be careful that you're putting P. aurelia in test tube number 1. Okay? Test tube number 2 is P. caudatum by himself. And then test tube number 3 is this. It's the two together. But I've made 2 separate columns for you. One for your populations of aurelia and one for your populations of caudatum. But they're both in test tube 3 together. Okay? So you're going to be counting that data. So, at this point in time, we're going to talk about where you're going to put that data in just a sec. But you're going to see that on the microscope slide, when you take a little sample out and you put it on the slide to stick it underneath the microscope to count your populations, your little bacteria, or your little Paramecium, you're going to see that
the slide only holds a 1/2 mil. But if you look at our data table, how does it state
A milliliter.
a milliliter?
So multiply by 2.
So multiply by 2, you got it. So every single data set that you calculate, that you quantify, multiply by 2, and you'll put those numbers in there respectively. Okay, so that's important. How do we get the data into a graph form from here? You put all the data in the table, you make all your calculations, you're done, day 16's in. How do you put the graph in? What do you do?
You, I forgot.
That's okay, work it out.
Do you like to put the graph in insert?
You are, you're gonna do insert, but before you do insert, you need to select and highlight everything you want to graph, okay?
You do that by clicking on the top box and pushing shift and going all the way down and then all the way across.
You got it, you got it. So highlight all of that, you're gonna go to insert, and you're going to insert a chart. Then you're gonna take that chart that you just made, once you get it all established the way you like, and you're gonna insert it right here. So the chart, the graph of your data will be here, and then you've got several questions that you're going to answer after you've collected the data and analyzed it on your chart. So we know what exponential growth looks like, we know what carrying capacity is now, we know we've got these 2 species doing what in a single test tube. What's that called?
Competition.
Competition, they're competing. Good, okay. So let me just show you a couple nuances on the lab itself. Let me go back up here, oops, not there. Back here, and let's click on, actually it is up there, sorry.
Can you see the difference in the species through a microscope? Like,
Can I what?
Through a microscope, can you tell which species?
That's when I'm gonna show you the nuances, yes you can. You certainly can. They actually have different morphology. So the shapes of them will look very, very different.
Oh
Oh
no,
no.
Windows Zodiac.
It seemed like it was freaking out on me just a second ago anyway, so I'm not surprised. So this is the lab, okay? Here's, see what I was saying? It says Caudatum first over here, but on your table, be careful because the first one is Aurelia. So you're gonna actually, I'm gonna work on this with this darn keyboard and see if I can figure it out for you here real quick. You're going to grab your sample, okay? It's just an interactive. You're gonna pick it up and you're gonna put it in test tube 1. It's got great sound effects, by the way. Okay? Then you're gonna pick up Caudatum for test tube number 2. Stick him in test tube number 2. 1 second, I'll answer your question. Okay? Now both of them are gonna go in test tube number 3. Oops. It's hard to see where I am right here from this angle.
You should use your fingers.
It won't work with the fingers, I tried. Yeah.
Doesn't it? Oh,
No, it doesn't drag.
does it? Dang, rip.
There we go. Okay, so now I've got my test tubes.
Does it just think you want to draw?
I think it does. So see, I'm highlighting hold on one second, I'm highlighting microscope. I'm gonna click on the microscope, make sure you're listening, Marvin. Okay? I'm gonna get a set of clean slides. So you'll see the little liquid divots in there, that's the 1/2 mil that we talked about. You've gotta multiply by 2 because you're doing the calculation for a full milliliter. It's on day 0. I'm gonna take my samples and I'm gonna plate them. So I'm gonna click here. There we go. Now they're plated, or they're on the slides and prepared and ready to go. Slide 1, which is my Aurelia, I stick it on my microscope, and I'm gonna put the grid on. Don't get confused. This 1 right here means test tube 1. So it's either gonna be a 1, 2, or 3 all time. Okay, depending on what test tube you put on under the microscope. So that's test tube 1. It'll tell you the genus and species that is on that tube, or in that tube. But the Aurelia has this rounded shape. Looks like a little cocci almost, which is a circular type of bacteria. But this is our paramecium right there, okay? That's Aurelia. So on this particular slide we have 1. If I went to my data table, what am I gonna write right there?
2.
I'm gonna put a 2, okay? If I go to my next one, where did he go? If I go to my next slide, I just simply go grab that next slide and I stick them there instead. So this can come off. See how Caudatum looks? He looks more like how in bacteria world, we call that a bacillus, like a rod shape. So one has a rod shape, one has a circular shape, a rounded shape to it. And you'll be able to differentiate between the two, especially when you're on test tube 3 and they're all on there together. So you're going to need to count one and then count the other and then put that data in the table accordingly. Okay? So that says day 0. Once you're kind of done with that day, you'll clear the slides and you'll flip the calendar to day 2. collect all your data. Everybody clear? So I'm gonna turn you loose. You've got, to make sure all your data table, your questions, your actual data collection table, and your graph are done and inserted. We'll work on the other questions. If time permits, today we'll do them. If not, we'll hit them next class period, okay? I'll come around and help anybody that needs help. Yep.
On the side.
The bridge?
No, I have to like go back to
Says what stuff?
go back to when I was just choosing figure out.
Oh, all the information, so you gotta actually, that would start. It's kind of pain, but that's what I would do.
I mean, are you?
It'll probably be the same data for that first round. Okay?
Yeah, I just wanted to, it says, this is 4 cells per milliliter, this is 4 cells per milliliter. Together, it's 10 milliliters, and this is only 5 milliliters. So don't you have to add 2 squirts, and then 1 of each?
Okay. Read over here on the side.
I did all that.
No, I don't think Will you guys over here just turn your volume down a little tiny bit? I love the interactive noises, but they're a little loud. Girls, you okay? Everybody don't let it work.
Oh, you're back.
It does, it will talk. But you know what data you're collecting, right? Cindy, are you okay? They just finished your analysis.
I have a question. If we haven't finished these questions, do we need to do it now or should we do it?
You can do it now. Yeah, I just wanted to get some people started on the lab since they were already to that place. So definitely finish those first, and you should have that hypothesis before you start. You okay, bud? Rob, what's that?
Michael Skate got random ones. Look, I did it, and I click on the thing, but then it just froze. How do we start? We take this.
Now I'm gonna go here.
Over here. Okay, and then click on microscope.
You're gonna click on your first slide and scoot it to the microscope.
Oh my gosh, I did it wrong.
As numbers start to get higher in populations, the grid is super helpful because you can be more methodical about counting.
Oh, and we have to see how many there is. We put on the graph. Which one? Day one. Oh, which one was that? Is the green one? Okay, so that was the.
Which one was that?
This one. So it's 1, so you have to times it by 2.
Correct. You got it.
And then the other one. Okay, this isn't that one.
Just go to the next slide. Okay. Lorenzo, you getting your data down? Let me see what you have in your table so far.
Are they all 2?
I messed up. I put the,
Quick reset.
Cut datum first.
Yeah.
So you've adjusted,
I flipped them.
you've addressed that,
What do
okay.
you mean mixed
Wait,
with?
so what do we put in the, like, in the last column?
Yeah.
Okay, so what does that say right there?
Oh, you're like growing in mixed culture.
You've got this guy in the mixed culture and this guy in the mixed culture.
Because this one, and you see how many are living in the mixed culture.
So come back and look at your graph here. You see what this says?
Okay, the Aurelia.
You've got caudatum and Aurelia in the mixed culture. So how did you get, my question for you is, how did you get 4 there?
Okay, let me go to the.
Oh, okay, so, so
They're all. You should do all of them, right?
Explain to me what you just did. How did you address your misconception?
because these are different.
Right, so which one's which?
This is,
I like to.
Caudatum, yeah, caudatum.
But I'm making go back.
Aurelia, yep. So you've got 1 and you've got 1. And then when you came over here, you've multiplied each of those by 2. So you were correct, this is actually right now. So you understand how to split that up now? Good.
It just means two again. It means, yeah. There's only one in there. Oh, 4. Or is it just number 2? No,
I
that's
need you
number
to
2.
do what's in the actual lab. So you're calculating your data right now. So have you, let's first go back here. Have you finished these? Finish those first, and then we'll come back and set up the lab for you, okay? Do you need help with any of those? Matthew, you okay? What are you on?
6.
I don't want to count. So my suggestion is, and this is what we do in the real laboratory. When I'm counting, when I used to do bacterial colonies with ETEC, we would actually use a grid system like that. And sometimes on the Petri, you're looking at basically the equivalent of a Petri dish, the way this looks here. If it was a Petri dish of colonies, I'd actually grid the Petri plate, and I would actually use a Sharpie and count my little colonies. In this case, this helps you methodically count through. So starting from quadrant to quadrant, like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then work your way across. Correct. You could even probably use some kind of marking tool if you wanted, but I think just the simple sheer counting as quickly as you can with a grid is your most efficient way of doing that, okay? But you want accurate numbers. You're a scientist. You need accurate data. Yep.
I push the X and it just X me out of the.
Oh, yeah, don't have top. So, see that?
Oh.
Two fingers, scroll down, clear slides, you got it. And then just flip your calendar. There you go. Oh, so I can do all of the days at once? You can do all of the days, which is in order, chronology. Use this little grid right here. Click on that, Amanda. It's way easier. Now methodically go across and count through your squares. It makes life so much better.
What should we do for the objectives?
So, if we were trying to figure out the why, the mission of this lab, where's a good place to look?
We're working with unicellular organisms and how they grow and how they interact with each other.
Okay, so we're talking about populations, right? We're talking about interspecies dependence and interactions, right? The way that they symbiotically work.
And is there competition
There is.
because of them being in the wild?
Totally. Look at what it says. Analyzing communities, populations, and competition. I would say, I would use that right there, the title. You're absolutely right. What's up, bud? You struggling? Where are you at now?
I just finished my hypothesis, so I'm about to.
Let me read what you wrote. Go back. I think alone they'll do really well and reach carrying capacity, but I think together they will both struggle. What kind of struggle is that? What do you call that? Bingo. All right. You okay?
627.
They're really different. Yours might be different from his. That's why I want you to individually do it.
See that makes sense? What's 27? I got 27.
Oh my. I'm on day 4. How do I change? It's 27 times.
Use the graph. You can also use a marking tool if you want.
And my computer just died.
Your computer just died?
Yeah, this happened when the sub came too. Just died.
Someone not plugged it in? What number is it?
3.
Wait, Miss, I have a question.
Let me get your freshman.
Thank you.
Yep.
So if it just, how do you calculate the number?
How can you what?
Like to find the number, for the first one you said it was 1 times 2, so is it just like the amount of things